So hello and welcome one and all. Today we're going to learn all about primitive recursion. It's not every day that you get to learn a life-changing skill, but today we're going to make one of those days. If you've never seen or heard of recursion before, I can almost guarantee that you'll be able to think differently about the world around you after watching this video. We're going to bend your mind a bit, and that's the aim today. We're going to cover primitive recursion in JavaScript, but this is not a programming tutorial per se. I'm going to start from the ground up, so no experience is required at all, just that you know how to save files and open a web browser, and that's pretty much all you need and you'll be good to go. If you want some new tools to help you achieve your goals in life, manage relationships or work-life balance, and if you need some new inspiring ways to motivate yourself to be successful, no matter how you define that success, playing with recursion and programming helps by giving your brain some practice in breaking larger problems down into smaller, reusable, more manageable parts and components. So deconstruction, in other words, is sort of the name of the game here. To do this, we're going to write a script that just multiplies numbers, but we're going to do it strictly using addition. And we're going to use recursion intentionally to process that addition into multiplications. So even if you have no experience programming, you can do it for the first time in your life right now while you're watching this video. But if you don't feel up to mucking about on the computer right now, that's fine too. You can still benefit greatly from watching me muddle through it, since I'll be stepping through every line of code I write to demonstrate the logical process involved in recursive programming as we go. So it's the thought process, in other words, the paradigm, that's our focus today, not the programming language itself per se. In just this one video, you're going to see a primitive recursion in action scripted from the ground up so you can get intimately acquainted with the concept of functions that call themselves recursively to arrive at a solution to a problem. We'll start by writing some simple functions so you can see what regular functions do in JavaScript and how they're used, and then we'll reuse those simple functions to build more complicated recursive functions on top of them. So the main objective to the project is just to write a function that multiplies any number we give it, given the function that we call. So I'll leave links in the finished file in the video description down below here, complete with comments and explanations of every step along the way. I do encourage you to try and learn to write the code for yourself first, and just use my guide if you get stuck. If you can't figure out what's going wrong with your code, then check the guide to see where you may have gotten lost. But the important part is the trial and error and the fiddling around with it. And when you check for help, just make sure that you're taking stock of the thought patterns and logic that you use that's not working, and compare that to the logic and patterns of the working example. That's how you're going to get the most out of this. So don't just write down the code that you know works and copy it word for word and give yourself credit for figuring it out. Actually do the process of figuring it out and writing it down and seeing the errors for yourself, because that's what's going to give you the most benefit. This channel features no ads begging for your money or attention, so there's no further ados than to remind you to show your support for our content by clicking that thumbs up button to show your appreciation. You can share this video with your ambitious friends or anyone you know who likes to learn or do puzzles. Everyone's brain loves to do some mental gymnastics from time to time, and this is a great way to do that. Also be sure to subscribe to the channel so that you don't miss our weekly podcast where we discuss socially conscious topics ranging from history and economics to love and religion and everything in between. So with all that aside, let's just dive right in. I guess first off, if I'm going too fast or too slow for you to follow, maybe don't forget you can pause, rewind, or skip ahead and things like that. This is a video after all, and there's no shame or harm in doing so. I'm going to start off by describing the objective for this video more plainly, namely to see and witness primitive recursion in action using JavaScript in a web browser. That's basically our modus operandi today. So before we get into the code and all that, I should just elaborate a bit more on what recursion actually is and give you a brief introduction to JavaScript so that you can more easily reason through some of the code I'm going to be writing and walking you through. So I've never tried recording a session while writing code before, so hopefully this all works out in one go, but chances are I'm going to make a couple errors here and there, but seeing me make the errors will probably help you figure out your errors too as you go along, because writing code and programming is nothing to do with writing it down the first time and it just working. Usually you spend about 30% of the time writing code and the other 69% or whatever you spend debugging it. Maybe 1% you spend testing it if you're really diligent, which most programmers don't test very much, but it's supposed to be in there somewhere. So to start off, what is primitive recursion? It's the mental equivalent of making a simple robot that just builds other robots. So you can imagine how this type of thought process can quickly get confusing and complicated, so don't worry if you feel that way at first. You're definitely not alone in that regard. Every seasoned programmer gets stumped by recursive programming because we're all human, and this type of thinking is just complex for all humans. It's just the nature of the beast. But the key is, for heavy and hard as it seems, when you break it down like I'm about to show you, anybody can learn to do it, and it just takes some practice to be able to learn to read it more quickly and readily. So we're not here just to teach some useful scripting skills. It's mostly to help everyone learn to think about problem solving in a completely new way. In programming, there are always many ways of doing the same thing or tackling the same problem, but most of the time you'll want to use built-in functions to more quickly and legibly get what you want done. But if your approach to writing code is kind of like a puzzle, you can challenge yourself to do things in a way that forces your brain to sort of build out your solution in a new way, even though you know how to do it another way, hands down. And that's the part of writing code that strongly encourages you to think differently, rather than using what you already know. It's also a good approach to do this and force yourself to use newly learned tool as another example to practice looking at the documentation or tutorials for programming language that you're using, because that process is the same with any programming language. So if you're interested in coding or technology, that's a great way to get practiced at checking documentation, which is a huge part of all programming because nobody memorizes every built-in function from every programming language. They're constantly checking and referencing the original documentation. So why is recursion so useful to practice, you might ask? If you consider how rare it is we experience a day in our lives that helps us see the rest of our lives in a different light, with more creativity, more clarity, more wisdom, then this video is going to lead you in that direction. By the end of this video, you'll be able to have a new way of conceptualizing problem solving, and it's the concepts that extend far beyond the programming and abstract logic itself. It can change the way you approach complex problems in every area of your life, and this practice of tackling problems to force yourself to do it differently, from managing warehouses to scheduling employees to leadership and executive roles, yada yada yada. That process of breaking it down into smaller, more manageable components is what's most useful and helpful in problem solving in all areas of life, not just goals and objectives and achievements or careers. It's pretty much applicable to absolutely anything that you find overwhelming or for its own complexity. It's a method of deconstructing large problems down to their primitive components and then building solutions out of primitive solutions. So, for example, let's say the problem you're trying to solve is figuring out which days you're going to be busy. If you commit to working hard every single day, and you commit to going to work every single day that you're scheduled to work, then you don't need to look at your schedule down the road to figure out which specific days you're going to need to work hard and which days you can come in late based on the workload. That mental load of different days being different goes away. So the buildup of differences over time is wiped out by two clear and precise flawless commitments. One is to be on time, and the second is to work hard. So it may be harder for you to work hard every single day than it would have been to just work hard some days. But in the long run, it will be steady and easy to answer the question, if that's our goal, is to answer this question most effectively and efficiently and easily, whether or not today is going to be a hard day or a light day, or tomorrow or June 4th at 3 p.m. year 2077. It just doesn't matter. If her goal was simply to answer the question, what will this particular day be like, then all complicated factors like weather and health and volumes and season, none of these factors matter because we've simplified the way of arriving at our answer by investing a bit more time and energy every day instead of spending energy figuring out which days to work hard and which days not to. So you always quickly and efficiently know the answer at first glance every single time you ask the question. Your day will be steadily the same as the day prior and the day after because a small set of rules that you applied universally from the start. So the easy days will be less easy, but as a result, the harder days will also be less hard, thanks to the preparation made from working harder on these easier days. So it seems like a little bit of a pedestrian example, but you can think of it like problem solving with primitive recursion. The reason why we call it primitive recursion, and I'm not saying that we're going to be learning regular recursion is because primitive recursion builds specifically on fundamental building blocks that are irreducible, basically. And we'll get into that with the first functions that we start writing in our code, because we'll need them to build on later to make a primitive recursive function. The recursion part is the process of the code, the function calling itself from within itself. And that's that mental gymnastics that I was speaking of before that's really beneficial and helpful to practice. And that's the part that's sort of like a puzzle, is being able to weave those pieces together without getting stuck in an infinite loop, which is a very huge risk whenever you run recursive scripts. So I'm not suggesting that this is the best approach to fixing all problems in all cases, but what I am suggesting is that if you're ever stuck on a hard problem and don't know how to start, or if you want to be sure to reach your goals without constantly having to reassess or readjust your efforts every day, then recursion is there to help you solve complex problems with minimal mental load. When you structure the solution to a common problem using recursion, you're applying the mental load at the start of the process as you build up your recursive function, so that you can forget the complications and details forever after while still arriving at the intended target or outcome. So you always wind up with the right answer, and you never have to second guess the variable factors as time goes by if you've set up a firm foundation of functionality from the beginning, from the onset. All you have to do is look at the step in front of you and say, I just need to take this one more step. So other examples would be like child rearing. If you set an example for your child every day, you don't need to reconsider whether or not you need to hide or censor yourself in any given moment. If you apply the simple rule, like not swearing in the house even if the kids are around, you just never swear in your house, you're far less likely to swear by accident while they're home, and thus failing to meet or achieve your goal. Another example might be to learn a new language. If you pick up one word per day and make a point to practice reminding yourself that word all day, after a year you'll know and have remembered 365 words. That simple daily procedure of just, I need to learn one word a day, instead of setting time aside to memorize tables of grammatical structures and have complicated lesson plans drawn up, and those are important things, but oftentimes we don't start big tasks or big projects that we want to have done in our lives that are really meaningful and truly give us fulfillment in life because of how gargantuan the task may seem when looked at as a whole. By just focusing on duty today and not having to make a lesson plan for ourselves every single day, it's much easier to stay motivated to make a routine of learning rather than to think we don't have time or that we'll do it tomorrow and procrastinate. So, knowing that tomorrow's task is the same as today's and completing those small tasks diligently leads us to our larger goal without all the burden that comes with the greater goals of our mental load. That's the optimal solution sometimes when the goal is too large to keep in mind at all time with all factors, such as trying to learn a language and conjugation of verbs and tenses and all that. Another example of how to apply recursive thinking, the concept or the thought process, would be like if you want to publish a book at some point in your life. Start by writing 1 page a day. Eventually it will get cohesive and not all of what you write will be used, but if you set the time aside and train yourself to write as a matter of routine and practice, you will definitely be closer to publishing a book than setting a huge amount of time aside all at once and expecting yourself to produce Chaucer on your first try. Not to belabor the point, but let me just give you another example here, is like starting a new job sometimes feels really overwhelming. You might know what you're doing because you've studied it and trained it, but starting out in a field that you've studied is very different than actually getting to an office and working in that job, or getting to a job site and working in that job. So the workplace and the new responsibilities probably don't leave you feeling confident right from day one. And if that feels overwhelming, you can take a recursive approach to solving this problem in your work so that you incrementally acclimate yourself to the new environment, forms, and protocols, etc., so that you find it easier to adjust than trying to do everything all at once or expecting yourself to grasp everything immediately, which is unrealistic, and it's not really fair to your self-esteem. So start by getting used to the look of forms and data on them. Get used to knowing where to look and relieve all that stress of looking things up when nothing around looks familiar and your scatterbrain trying to figure out where this piece of information is that you need, that you should know. After getting used to looking up information, the daily routine might be to review completed assignments from the past to get familiar with what the expected output is supposed to look like. Thus, again, just reducing that mental load of everything being constantly new and distracting you from the target goal that you have set out in front of you. So recursion and recursive problem solving is a path toward life goals and significant achievement. Successful people share similar routines and habits, whether they realize it or not. Approaching problems with the mentality of primitive recursion is a way of demonstrating complexity to make it easier to steer your actions and energies toward a productive outcome. It's not about finishing or the final calculation that defines success. It's the routine of constantly inching closer to what you want to end up with in a whole variety of directions at the same time, because you need only focus on the steps in front of you every day. The long-term desired result is inevitable once you've got the steps figured out. Thinking about long-term goals then on a constant basis would otherwise be exhausting, because all of the steps and all of the variables along the way need to be constantly considered and reassessed and readjusted. But by focusing on just what's directly in front of you, with the trust that you can safely ignore all the minutiae of details that you've set aside between the start and the finish line, it leaves you able to tackle several long-term goals all at the same time without being overloaded by the steps of all those targets individually. So we're learning recursion in code because it makes our brain bend in trying to solve a simple problem in a difficult way, and that's the point. So it may feel uncomfortable, but treat it like a puzzle that you can design and change as you go along. Every time you find a new block or piece, it's like learning a new programming instruction or pattern. This mindset, this concept of recursive programming, is teaching your brain to optimize itself for problem solving in everyday life. And that's why it feels so uncomfortable at first, is because it's a novel way of approaching ideas rather than just spitting them out as your first gut reaction. But just practicing anything, it gets easier and more fun the more you do it, and the better you get at doing it. So it's a lot like Sudoku puzzles. If you try and figure out all the numbers just from looking at it up front, it's almost impossible. But if you break it down into its constituent tasks of isolating one block, isolating another block, checking the lines, checking the horizontal, checking the vertical, and then checking that you don't repeat numbers within the same block, that type of thing. When you break down the big problem into a small, manageable problem, and then work at it recursively over the entire puzzle, that's how you figure out a Sudoku. Tower of Hanoi is another good example of when recursive thought is good practice for solving a problem. So you may get the feeling as we write more and more code here that out of nowhere you'll just see like a wall of cryptic text and then start feeling overwhelmed by that. But don't give in to that feeling. That's the exercise here. The point of this video is to show you a new way of thinking, so it's going to take some getting used to. All things worthwhile feel a bit heavy at first, but it's not about getting the right answer as quickly as possible and moving on. It's about getting used to the new mode of approach. The process of thought, again, is what we're after. So it's important to bear in mind, too, that this isn't intended to be a programming lesson, although we're going to be using JavaScript programming language. The reason I'm taking you through JavaScript is threefold. JavaScript is super useful to everybody and anybody prototyping ideas or automating calculations. You could do this in a spreadsheet for sure, but you could also do this in code. And sometimes when you want to express a problem mathematically that you know in words, it's easier to do it in code than to figure out the formula and put the formula into Excel and then reformulate the words to come out for the answer after the Excel spreadsheet does the computation for you. In code, you can basically write it in plain English once you know the lingo and the jargon. And then you can more easily reflect an output that's more readable for you in the process because it's written in English, as opposed to just formula in a cell. Secondly, we want to work with JavaScript because it's accessible and flexible. It still throws syntax errors if you don't write everything exactly as it prefers, but as you'll see, it'll run without complaining if we forget semicolons at the end of each line of code that we write, which some programming languages are very, very stickler for that. It's forgiving in many cases too, where other programming languages are not, in the empty spaces inside the code as well as the indentation. And we use indentation just to organize our code so that we know which blocks of code are being contained within another block of code. And again, I'll get into that more as we start typing. But just so that you know, there are some programming languages like Python where if you have an extra space or an extra indent, it's really hard to catch those errors because a space is just an empty space. But it will crash your entire code if you mess that up. But JavaScript, you don't have that problem. So the third reason we're going to use JavaScript is that it's a flexible language in how it processes its code. Knowing data types we'll cover very, very briefly, but data types for variables is important in most programming languages. Indeed, it is also important in JavaScript, but JavaScript you can mutate variables, so you can change its purpose on the fly as you go whenever you want. Whereas other programming languages might throw an error if you try and put text in a block that it's expecting a number. Or if you try and put a number into a block that's expecting a list, for example. So lastly, JavaScript, and the reason we're going to be using it, to get familiar with it is just because it's used to make websites and all kinds of other platforms like React and web applications, and even for your cell phone, your Android and Apple apps. Those can all be written in JavaScript frameworks too, which are sort of extensions of the JavaScript language. But remember how we said how flexible JavaScript is? You can use it to basically create another language inside of it, more or less. It'll still have to follow its regular syntax rules, but React is an excellent example of how you can just repurpose functions to output actual objects and components on a website. And every company uses websites. Websites are excellent tools for promoting businesses, but also for things like mail merges and email lists and subscriber lists and things like that. So JavaScript is usually the go-to tool just to like curry things together, different parts of like an HTML page with a database, with a server call, etc. So any complicated thing you want to do in the future, you're going to have to know JavaScript just to piece them together and make them visible. So with that, all the laborious intensities aside, let us go straight to writing our code. So you can see here, I've just got a blank screen. I've opened up a folder I'm going to start working in, and I'm using Linux, so this will probably look a little bit different for you if you're using Windows or Mac, but in premise, everything should be the same. I'm just going to right-click the background here, and under Windows, it'll say New. Usually it's at the bottom there, but I'm going to say Create New Document, Empty Document. And I'm going to name it anything. Just make sure at the end you write .htm or HTML, and then hit Enter. Now I'm going to need a web browser to display my code. So let's just open a web browser here. And I'm just going to drag this file I just created, the HTML file, into my web browser, and that's that. Now, if you are running Chrome, you can just, with the web browser selected, hit Control-Shift-I, and it'll open up the console. It actually gives you a whole bunch of different tabs here, but the one we're looking for is console. Maybe I'll make this a bit bigger so you can actually see it. So this is the web page here, but we're not going to use the web page at all. We're going to do all our code and output our results into the console just to make things straightforward and easy. And as you can see, the console is very simply a space where you can write code in. So you can say hello world, and then when I say X, the response is hello world, because that's the value of X. So you can write code directly in here, like function out console log A. So all I'm doing is making a function that outputs a console log of anything I give the function. In this case, I just called it A right here. So when I hit enter, now when I say out, this is my output function. And then I wrap those in the parentheses. Functions always have parentheses. You'll notice that it output my result here. This is my output function. Now, if I hit refresh on the page, which is also Control-I, you'll notice that if I try that same code again, I get an error. And this is because anything I write in this console here is only live until I refresh it. Nothing's saved. So that's why we've named this file here, and we've opened up this browser with this file in it, because we're going to use a text editor so that we can save all the code that we write. And then we're going to save the file and then refresh the page, and that's how we're going to see our output code. Another way to open up the console is to check this 3 dots here. Go to More Tools, and then in here somewhere you get Developer Tools, something like that. Hold on. Oh, it's these 3 dots up here. So More Tools, Developer Tools, and then you'll get these across the top. And again, you might have something that looks a little bit different because these are all different tabs up here. But you just got to make sure you've got the console selected. Now, I actually don't like the look of that one, so I'm going to open a darker browser just to make it easier on my eyes. And again, I have Chrome open, Chromium, so I can Control Shift and then I, and it opens my console here. So to start off, maybe also you can switch the sides and where you put the console, but I think for our purposes, I'm actually going to hit this and see this little 2 windows here. You can detach the console. Let me change that to console. And that way I don't need the whole page open. And I can make this a bit bigger so we can see what's actually going on. There we go. So now you can use any text editor, even Notepad works. I'm going to use Sublime Text. It's free, if you don't mind it asking you to pay for it every once in a while. And again, I can take my file, just drag it straight in there, and now you'll see the name of my file up at the top here, as I'm trying to point to the screen, newbie. So first things first, we need an HTML file, some markup. Because we're going to use HTML, the web page markup language, which is what HTML stands for, hypertext markup language. We're going to use that to embed some of our HTML. Doc type HTML. Actually, you don't need to see my face anymore. So now that we've got our notepad set up and we've got our browser open and they're both reading from the same file, I'm going to, you don't need to keep seeing my face here, I'm just going to switch that out. There we go. So first things first, we've got this file here, but we need to start displaying some JavaScript. So we're going to do some HTML, which is just regular web page markup. Oh, maybe I should move my... There we go. So, web pages have a head, they have a body, and inside that body, I just need a script tag. And we do need this for some browsers, so I'm just going to write it in to make sure that everybody who's following along also doesn't have any troubles that are unrelated to the actual code. And close the script. Oops. Give us some room here. So now everything we type inside of this area here, between this and this tag, is going to be our JavaScript. So first things first, let's just do a quick test. Do a console log start of script. Now I'm going to go to File, Save, select on this side, and then hit refresh. More tools, developer tools, and here we go. And again, if your console looks different from mine, all you need to do is check these 3 dots right here, and it says exactly where it docks the pane to. So you can have it docked to the side if you'd like, or more tools, developer tools, dock to the right if that's easier for you. So this is the web page here, this is the console over here, and you can see we've got start of script just like that. So I'm going to add a title just for my page, and when I Control S and save there here, and then Control R to refresh over here, you can see a console logs that that line of code, and it even tells you which line I wrote it at. So line number 6. Let's just get rid of that. And so yeah, as you'll see, this title here, this is all just HTML. It's a markup language. It just tells the web browser how you'd like things to display, and that's what appears up here. So let's just get you a little bit more familiar with JavaScript. So double slashes are, slashers are comments. This line will be ignored by the compiler. So we've got double slashes, and this is just so we can make notes for ourselves without screwing up any of the any of our code and process. Actually, let me just see. There we go. I've got some stuff I've already pre-written, which may be a little bit easier to read. So yeah, we'll start with data types. Basically, you've got text data type, which is just strings. You've got integers, which are numbers. You've also got floats, which are decimal points, floating point numbers, but we're not going to use those today. We are going to use a list a little bit. And we're going to use a lot of the console.log. So I'm going to keep showing you that over and over again so that we can get some feedback from the programming compiler over here. So if I Control S to save and then Control R, actually let's put some of that in here too. So Alt plus Tab switches between open windows. Control plus R reloads the web browser, and Control plus S saves the page. So those are going to be the quick commands. You're going to see I go back and forth like this, like this. You can see it's changing the cursor from over here to over here, and that's just changing our view, our focus, I should say. So notice when I make an array, which is a list in open brackets here, I can input any type of data values in here, and they're all separated by a comma. So this is the first index, this is the second index, this is the third index, and this string variable that I've made up here, which means all of this is in this index here. And then after that, I've got another string variable, which is this one here, and that includes all of this. Okay, so in making a list, when you console log it, you get this nice little drop-down thing here, and every time you use a list, you get an index for the values based on the order that they've been entered into your list, and this is what makes them super handy. I'm going to use the terms interchangeably, list and array, but just know that they mean the same thing. And we'll get into how these are used at some point in this video as well. But the objective of this tutorial is going to be to avoid using it and use primitive recursion instead. So for anybody who's not familiar with JavaScript, I'll just include some extra information here just for your own eyes and some other examples of our console.logs. And we're going to start by, give ourselves some room here. We're going to start by writing some simple functions just so we get the hang of how JavaScript works. So we're not exactly sure how I want to tackle this, but let's just start with the bits and pieces that we know how to tackle. So I'm going to use a keyword function, and that's what we use in JavaScript to define a function. I'm going to name that function 0 because I want to make a function that always gives us 0 no matter what number we put into it. This is one of those primitive functions that we were talking about before that we're going to use as a building block to make primitive recursive functions later on. But right now I'm just going to show you how the programming syntax works. You'll notice how my text editor gives me an indent here, and that's not necessary for the code to run, but it'll help us visually tell which parts of code are contained within which blocks. And these curly braces here are going to be all the commands and instructions that are executed when we call this function. So first we define the function by using a definition, and then we give it a name. This can be anything. You can call this anything you want, but not without spaces, of course. Usually we'll use camel case. Camel case like that if you want to use separate words all in one variable name, or you can also choose to use underscores if you like. An underscore is a completely valid character, but in naming your variables, you really want to make them specific as just a standard practice so that it's easy to tell just at first glance what they're for and what they do. So in this case, I'm going to make a function that no matter what number you give it, it always returns 0. And I'm going to use return, which is a function keyword in the programming language, which tells you, okay, this function is completely done. This is the output that I want to give. And I'm going to say return 0 because every time I get this call, I want it to come back as 0. In the programming language for JavaScript, you'll see me sometimes probably just out of force of habit because I've been writing JavaScript since I was young, and back then you actually had to include the semicolons or the whole thing would crash, but luckily it's not an issue anymore. The browser can just read around it, so I'm going to try and omit them just so that there's as little text on here as possible, just so that it doesn't get too overwhelming. And I've pre-prepared a few comments and stuff that'll help us out, and maybe I'll just include those as we go along too, just for more detailed reference, but I won't necessarily comment on all of them explicitly in the video. So let's try our 0 function. First let's save this and see if we get any errors. So I'm gonna make this window active and hit Control-R to refresh it, and you'll see here's our list that we get on line 24. And if you look at line 24 in our text editor, remember these are just 2 separate windows. They're nothing fancy here. It's just a text editor on one side that I've resized and a web browser on the other side. So here is our list that we had made on line 24. We said console log list array. Well, what's our list array? It's this. And everything contained in brackets, these square brackets here, separated by commas, constitutes different items of values which are indexed in the array in the order that they are appearing on here, which you'll see the indexes always start at 0 in programming language. Well, not all programming languages, but most of them just start at 0. So it's good practice to get used to that as well. But in case you're not sure, you can always just console log whatever variable you got, and the console will faithfully and dutifully show you exactly what's contained in those variables, which is very handy. The next line here is line 41, and if we go down to line 41, that's what I wrote here. And for example, int variable is : that's all contained in this string of text, and int number is our last console log here. So I don't really want to show this every single time, so I'm going to comment that out for now. But it's there just in case you need the reference later on. I'm going to comment this one out, and start of script we'll leave that on just for reference to make sure we know our code is running. Now, we've got our 0 function. We should probably test that. So let's just make a variable. my new variable. And remember, you don't want to use words that the programming language might consider keywords, like the word console. You'll note because console is a built-in function, console.log is a built-in function. That's what these parentheses mean. I can call it as a function, and I can give it instruction. I don't really know. I can tell it display this, right? And it'll do that. Because it's a built-in function, it's not something that I've written or built myself. So if you tried to make a variable with the name console, it's not going to let you, because you'll just confuse the compiler. So make sure that your variables are completely unique to anything that wouldn't be built in before you do anything. And then let's say this is a test. And now I want to call the function 0, and I'm going to give it my new variable. And let's assign that as we'll call it result for now. Result equals 0. And that's what this return command is going to do here within the function. So when you call it, it's going to return this number, so that all of this basically winds up just equaling 0 after it finishes processing. That's the goal for it. And let's just see if we console log my new variable and result. And you'll notice my text editor is it's giving me some autocomplete options. This is really useful. So getting a programming text editor versus a just using Notepad or something like that, you don't get the benefits of all the color coordination. So like it'll give you a visual cue if you're trying to use a word that's already, you'll notice how these ones are all white. But if I tried to make a variable that started with console, it would show up as blue. And now that I've defined my function 0, even if I try typing 0, see, it'll give me an autocomplete because I've already typed it before, and that'll help with avoiding typos, because the last thing you want is for your logic to be sound and then you're sitting there fussing over all your programming and code and thinking something's wrong with it, when in reality it's just a typo. And that happens all the time. So again, our objective is we're going to make a primitive recursive multiplying function without using the multiply symbol. So let's make some more of our primitives here. We're going to need an add 1. So whatever number I give it, and you can make this anything you want, really. Anything you want. This is just a variable, and it's going to be used inside of the function. It's limited to just the function scope, that is between these two curly braces. And that's so that we can tell it exactly what's going to happen when we call the function. So just like we used our console.log, which is a built-in function, everything we put in here is what it's going to print out to the console in the web browser, which we've opened here. Again, Control-Shift-I if you're using Chrome, Control-Shift-J I think if you're using Edge, and Control-Shift-K if you're on Mac, I believe. I might have got those mixed up. But anyway, so what we're basically saying is we're going to make a function where every time we call it, it's going to take a number, and the result that it returns is going to be whatever the number is that we gave it plus 1. That's the whole point and purpose of the function. All it does is increment a value by 1. So this one can be simply stated as return num plus 1. And remember, you want to make sure you don't use quotation marks, as I almost typoed, because if you do this, it's not the number 1, it's the text character of 1. And it can't do computations on a text character. It can add two pieces of text together, but it can't do math on a data type of string. It needs to be a data type of a number. So without using the quotes, that's what you're giving it, is just the data type of number. And this is one of those things that JavaScript is nice for, because you can simply define the data type just by assigning a variable a value, and it'll say, oh, well, the value you assigned to me is a string, so this variable must be a string. That sort of thing. So function, I'm going to need a -1 if I also have an add 1. And we're going to get a little bit clever here because I just want to have some fun with this. We're going to say num plus -1, just to show you how we can change things up a bit, and maybe we'll do this multiply without even needing to subtract. So we're going to make a multiply function without using multiply. So first, based on these formats, let me just show you what a regular multiply function looks like. So again, I'm going to have it input a number, and the return value is just that number times, I guess I'll need two numbers if I'm going to be multiplying stuff. So we'll call this num1, because I'm going to reference it here, and then we'll call this one num2, so I reference it here. So this is kind of cheating. If this is the end of our program, we'd be done, because our objective is just to multiply two numbers, right? So if I did console.log regular multiply function, and I just give it 2 and 4, remember I'm separating these two values by a comma because I'm not doing the math in here. I'm passing this 3 into num1 and this 4 into num2, and then when I'm calling this function with these two parameters, it's going to use them both to return the value for me. And if I just Control S to save that, Alt Tab to go to my screen over here, and then Control R again to refresh, you'll see, remember I commented out all those console.logs, so the only thing we're going to see here is line 6, way up here where we started our script, and 12, because we did 3 times 4, that's num1 times num2, and that would be the cheating way of doing this. Another way of doing it might be, well, let's get a little bit more complicated just so you get used to seeing functions. So let's do it with a loop. Oops. So num1, number 2, and remember you can change these to anything you want. I'm just going to keep them consistent so it's easier for us to track them. If we keep using different words, it's just harder to follow along. So I'm going to say let first var equal num1, let second var equal num2, let result equal first var. So what I'm going to do here is I'm going to make an adder that loops through all of any numbers that we offer our function here. In this case, we're just using 2, but in practice, you could use as many as you want. And I'm just going to show you how a loop works, because what I'm going to write here is second var. Conceptually, this is what we'll be doing with recursion, but we're going to be doing it instead of containing it in a loop. As you can see, while is a predetermined keyword for the programming language. It denotes that as long as everything in this parentheses is true, it's going to keep doing a loop. So you got to be careful that whenever you use a loop like this, you make sure that you change the variable that that's being computed to see whether it's true or not. Otherwise, it'll run infinitely, and you can freeze your browser. I mean, it doesn't break your computer or anything. It's just annoying because you got to wait for it to unfreeze and then close it and whatever. But we're going to start off simple here with just a while loop. So while second var, which is this one here, which equals number 2, which is going to be the second item that we place inside of our loop adder parentheses. And you'll notice this block of code is indented inside the function code, which itself opens and closes here. So another advantage to using a text editor is you see these little underlines? It helps you keep track of all these opening and closing brackets and parentheses, which is very helpful once you start getting further along into programming. So I'm going to write here second var. I have to make sure that it decreases, because if it's always above 0, it's just going to keep looping, right? So let's use our -1 function. Second var equals -1. And we'll put second var inside of it, just so you can start to get a glimpse at how recursion works. So here's an example where people can start to get confused, and it makes complete sense, but you get used to it the more you do it. What we're saying is, while the second number that we enter into our function call is greater than 0, we want it to do something. But before I do anything else, I want to make sure this doesn't fall into an infinite loop. So I'm going to make sure every time it loops, this number, whatever I gave it, is going to be processed through our -1 function. Remember, our -1 function, all it does is takes in a number and spits out the same number, but -1. And that'll just keep us from falling into an infinite loop. And if you'd like, you can even write a console.log in here and just test it to make sure that everything works before moving ahead. So I'm going to hit Control S to save, Alt Tab to go to my browser, and then Control R to reload. Oh, you'll notice it hasn't done anything because all I've done is define the function. I need to call it for it to do something. And to call it, all we do is use the word we named it, loop adder, and we got to throw some numbers in. So we did 3 and 4 last time. Let's do 2 and 5. Oop. So Control S to save, Alt Tab to shift over, and Control R. And now you'll see every time second var is running through our loop, it prints out what the value is, and it goes all the way down to 0 until it stops looping at 0. So I'm going to start speeding up a little bit now that we've got the concept of loops down, and you can see how something can be made equal to itself, but processed by another function first. This isn't recursive yet, but we're sort of getting there, because we're going to start making functions, like a function definition like this, that also calls itself from within itself, and we got to make sure that we avoid any infinite loops in that regard as well. So this result here, I'm just making it equal to num1. And again, this isn't for proper programming etiquette or practice or anything. It's just to show you how you can manipulate all the numbers and stuff through your definitions. So I've assigned a variable that I've just made up, this can be anything at all, to the first number that you enter when you call the loop adder function. So if this is 1 and this is 4, first var, I'm just saying, is equal to num1. Second var is equal to num2. The result, I'm making it just as an initial value equaling to num1. Now result, what I want to do in my loop is, remember how I said we've got the second var counting down? So every time it goes through and processes one part of the loop, it equals itself -1, but I'm also going to add 1 to the result. And by doing this, we're basically doing a computation with the while loop. So like every time this is, the code inside of here is run as a loop until this number decreases down to 0, I'm going to be adding 1 every step of the process as well. And that's going to, let's console log that too actually, at the end of the function. Console.log result. So as you can see on our line 81 here, line 81 up here, you get the answer of 5. And why is that 5? It's because result is 1 when we first run the function. Remember, the first position is num1, and then 5 is the number, or 4 is the number of num2, and then 4, the first time it runs, is greater than 0, yes, -1, result adds 1. Then you run the loop again. 3 is greater than 0. So now second var, instead of 3, now equals 2, result +1. Second var then equals 2, which is greater than 0. Second var -1 makes the value of 2 go down to 1, and then it adds 1 to the result. And then again, 1 is greater than 0, so it runs again. And that's how we amount our result to 5, because we started off first var, we started off at 1, then we ran through this number 4 times because num2 was used as second var, and second var was used to see, is it true that this number is over 0, greater than 0, and then second var equals itself, but inside of a function that decrements, another way of saying incrementally decreasing. It decrements by 1 because we've defined this up here, -1 and add 1. So we're using a small primitive function that we've built inside of a loop, which is also pre-built, and we're adding to our result incrementally with every iteration of the loop. So every time we step through that loop, we call that an iteration. So if we loop 5 times, there are 5 iterations. In this case, we looped it 4 times, but we started at the value of 1, and that's how we outcome in our console log the value of 5. So how do we do this recursively? Let me just check my OBS here. There we go. This might help me explain it a little bit. Okay. So, in a recursive function, the way we call it is we're going to build the function the same as we built before, but we're going to need an extra value to add into our parameters, those parentheses, when we're defining our function up at the top up here. And we're going to need those so that we can carry a value forward to the next time we call the function. And that's basically going to tell us when to stop. So instead of having this second var -1 and loop while this number is greater than 0, like we did here, we're going to make the function call itself be part of the loop. And that's the mental gymnastics and the difficulty part of writing recursive functions. So let's start with an adder, because I'm going to use an addition function, this function that we write right now. I'm going to use that to inside of my multiplying function, and I'm going to use a multiplying function recursively as well. So that'll be good practice for us. So let's say this one is first, and we're going to equal num1. And the reason why I'm using, let is just another keyword. It defines variable scope. I don't really want to go into too much detail, but technically JavaScript will still work without it. So you can use it without or with it, but best practice to do it with it. Because then it just tells you, it tells the programming, or the browser, I should say, how far out of these parentheses those variables can be used. And if I didn't use it, if I didn't use let, I would run the risk of reusing a first and second variable in another function call and then having them cross over each other, and then your program won't work properly. So actually, maybe I will use it in this case just because it's best to see it regularly, and that way you don't trip yourself. We're going to need a result. Oops. So result is going to be my carry value, I think, to start. And you'll see that I wrote carry value wrong here, and I wrote up here equals 0. What I'm basically just saying is that if I get no value for a third number here, then just default to 0. But if I give it a value, then ignore this equal to 0. So for example, see there I did the semicolon again. So for example, if I were to call my recursive adder just by this, I would want a number here, and then the carry value, if I don't enter anything, will automatically be 0, but if I give it a third number, it's going to use this third number that I used and plug that into result right from the start of the function. So that's important to note, because that default is it's just shorthand so that I don't have to confuse you with a whole bunch of extra code that's unnecessary. So we're going to need a condition. That way we can say, if this is true, do this, and if it's not true, do that. But the reason why we need at least one condition is that we have to stop this from calling itself over and over and over again once I call recursive adder within itself. So to do that, I'm thinking, let's just do it this way. Second is greater than or equal to 1. And then you open and close curly braces again, and these just work the same every time you use them. I shouldn't say every time because objects are a bit different, but when you see these in definitions of functions, for example, everything within these main brackets is part of this function definition, and everything inside these ones is only related to this if statement here. This if is a keyword, so again, you can't use it as a variable, and this basically just processes a true or false and says, if whatever you put in here is true, then do all this stuff here, right till the ending of the curly braces. If this doesn't evaluate to true, then it does nothing. So this is sort of going to be how we help prevent ourselves from falling into an endless recursive loop. So let's first say result, let's use our add1 function. Add1 of result is what I want to do. First equals -1 first. So again, we're just using those functions we made up here. -1, add1. Obviously, it's much easier to just say first equals first plus 1, or another equivalent way of saying it would be first plus equals 1. This is just shorthand. They all mean the same. But I'm going to stick to using our functions, even though it looks a bit weird, because we built them, and that's what they're for. It's to help us practice calling functions and making functions. So, what do we want? First, got a result. If second is greater than or equal to 1, you're going to run this. So, we want second to do a -1. So yeah, I've already made some mistakes here. And this is the process of writing code. It's just a lot of going back and forth, and then once you've got your code all written and spread out, you can then do what's called refactoring, and that's just writing it in a more clean and concise, and usually a more logically, like processor-wise, a more logically consistent way of displaying your code. So second is result -1. And this right here is what's going to keep us from our function endlessly repeating itself. Sorry, typing and talking at the same time is a lot harder than it looks, apparently. So first, second, and result. Now remember, this recursive adder, this function that I'm calling here, this is inside of this function. That means when I run this function, if I didn't have this if statement there, it would call itself again, and then run this function, and then call itself again, and then run this function, and then call itself again, and it would just never finish. So this if statement is crucial, and the first thing you do after the if statement, if you're going to be writing any kind of loop that you want to make sure it doesn't run infinitely, you make sure that you do at least one line here to make this end at some point. You want to make sure it ends, and you want to make sure you spell properly, because typos do not work. Okay, so I guess if I do all this, I just want to return result at the end. So that takes care of one case. Else is another keyword. You can use it with only after you've put in an if statement. Otherwise, it doesn't know what else you mean or that you're referring to. So I'm going to give it another if statement, because basically what I want to say is I want to compare the first number to. If the first number is greater than or equal to 1, I want my result to equal add1 result. First equals -1 first. This prevents an infinite loop. Actually, I should write that on the other one too, just for posterity. Maybe I'll clean up the file and before I publish it, so that the one you download that you link to in the description might look a little bit differently. But if you're ever wondering, that's why. And I'll need results to equal the recursive adder, and again I'm going to use first, second, and result. And then I don't just want it to compute it and do nothing, I want it to actually tell me what the result is. So the next instruction here is to this return command. Again, anytime it reaches this keyword within this function when it's called, it'll end the entire function, but that's okay because our recursion happens before our return statements happen. And the only other case would be, I don't need to put in another edge case because this else pertains to this if, and this else pertains to this if. So if this doesn't happen, then this will happen. And if this doesn't happen, then this is going to happen. And this is just going to be our end case. When there's nothing left to do, all we do is return the result, because that result variable is going to accumulate over all of these successive recursions. And what else? So I'm setting result to be our carry value. So the first time we call it, it's going to be 0. And then if second is greater than or equal to 1, we're going to add 1 to our result. We're going to minus 1 to the second number because that's what we're looping from. We could have chosen the other one and just done first and first, and then changed this to second and second. Doesn't really matter which direction we go. And then our result, we're going to make it equal. Remember, we've changed it to whatever our third parameter is. We're going to use a recursive adder function, including result, inside of our carry value to keep that number accumulating over every iteration of our recursive function call. So hopefully that works. Let's see what we got here. Let's console.log answer. And let's make a variable called answer, and let's say that's equal to recursive adder, and let's just give it 2 numbers. We want to add 2 numbers together. Let's say 5 and 3. Oops. 5, 3. Now I'm going to save it here with Control S, shift over. Oops. Make sure I've got the window selected, and you'll see right down here on line 111, you've got the number 8. 110, we do the processing, and on 111, we actually print it to our console. So 3 and 5 is 8. Perfect, it works. Let's try and step through this quickly, just so that we get a firm understanding of recursion, and then we'll quickly run through how we make a recursive multiply function. So our recursive adder does what? We enter it in, we get 5 and 3. Those are our initial values. We didn't give it a third value, so this stays as 0. That means result here equals 0. Actually, let's see. Oops. So this is 0. Number 2 is 3. Number 1 is 5. So if second, which is number 2 here, value of 3, basically this is saying is 3 greater than 1, greater than or equal to 1. If it is, I'm going to take my result, add 1 to it. Second is then going to minus 1 in order that this doesn't loop infinitely when we call the recursive adder again. And remember, recursive adder is this entire function. But nothing else gets read after we see this return, because that's the keyword to jump out of our function and say, okay, we're all done, spit out this answer, good to go. But when we call this the second time from inside the function, whereas here we didn't have an extra number given for the parameter, now we're giving it result, which we've made, it was originally 0, first time we entered because that's the default value. Result equaled 0. Then we added 1 to it using our add 1 function from up here. Any number you give it, just return that plus 1. And then we want to make sure this loop doesn't keep going, so we use our minus 1 function. Again, we defined it way up here, same thing, num plus -1. Just another way of writing it. And we call this again. So these numbers then will be first is 5, Second is 3 minus 1, which is 2. So this is, 5, 2, and result is 1 because we said result equals plus 1 from the 0 that it started with. Now let's call the function again, but using these numbers here. So, just for some clarity, this second time we call it, the first number is going to be 5, the second number is going to be 2 instead of 3, and result is going to be 1 because that's the number we offered it here. Remember, the number we give the third value, that's the carry value parameter, also known as it's just a variable that you can use inside the function, but it's telling the function that we're expecting a number. If we don't get it, default to 0. So the carry value is 1. What happens here? Second is greater than 1, which it is because it's 2, greater than or equal to 1. We run this again. So result, we add 1 to it, so this becomes 2. Second, we minus 1 to it, so this becomes 1. First stays the same, and we run recursive adder again. Now you can see our result is now accumulating and it's adding into the next function call. So now the next time we run this, our result is going to be 2, second is going to be 1, and 5 is still going to be 5. So let's run through it again with these numbers, 5, 1, and 2, 5, 1, and 2, 5, 1, 2. Second greater than or equal to 1. Yes, 1 is equal to 1, so we're good there. Result, we'll add 1 to it. So now result equals 2. 3. Second is going to be negative 1 because we want to make sure that our script eventually stops looping. So this was our failsafe. As second becomes is decremented, then this if statement will stop getting caught every time we call this function. Result now equals recursive adder, which is this function that we're writing. It's this entire block, but we're not reading everything below the return because every time we return results, the function says, okay, I'm done, spits out a response. No need to carry on. Now this is where it gets interesting. Our next block we enter in is going to say first equals 5, as it always did, because that's the first number we put in. This 3, though, because we've been decrementing it every single time we run this if statement, and every single time we hit this if statement of is second greater than or equal to 1, we hit the recursive adder function and call ourselves again. And then we return that result, so we ignore all the stuff below. But this time, second is going to be 0, because we've decremented 3 times, so this whole statement here doesn't get read on this last call, and this is crucial. This is what we call the base case. So instead of running through that block of code, what we're going to do in here is first check if the first number is greater than or equal to 1. And now you can kind of see a pattern developing here. We're basically doing the same thing we did up here, but we're going to add to the result, the accumulating result, we're going to add to one at a time using the first variable as well. So result now equals add 1, just like we did up here. First now is going to be minus 1, and to tell it, well, what number do we start with? We enter first, and that's just, again, defined by up here. We can name this anything we want, call it something, and we just have to change it down here so that it matches and it knows what it's talking to. And this is contained entirely within just this block of code here, and that's what these curly braces are for, everywhere here. You can also put them all on one line if you'd like, just to keep things cleaner, because you don't really need all that space being taken up, but I'm just breaking it up and indenting everything to help you step through the code with me, because it's not entirely obvious if you're new to programming. So, as we said, we're just doing the same thing we did up here over and over and over again, and we're decreasing first every time we step through it to make sure that we eventually quit, and this function doesn't keep calling itself over and over for infinity and crashing our web browser. And in the exact same way that we did the first side, we're just going to use the result that we get and pass it into itself. So it's going to ignore this equals 0 value because that's just a default value for the first time we call it when we don't give it. We could even run the same code with a 0. It actually wouldn't change anything whatsoever. But you could also play with the formula or with the function and muck it up by using a number that you're not supposed to. But we're going to get to that later too. We're going to figure out how to use these primitive functions inside of other functions. That way we can add as many different parameters as we want. Or another word of saying it is arguments. We can give this function as many arguments as we want. And it's going to run through this code exactly the same for however many arguments we give it. And that's sort of the power of recursion in programming. So just to cut things short, after we've done our recursive call and our result is accumulated, we've accumulated all the numbers from 1 and we just did them one at a time. Add 1 to result, run it again. Add 1 to result, run it again. Now we're doing everything from num1, which is our first number, because we said first just equals num1. We're going to call our recursive adder over and over again. Second is just going to be 0 every time because we've decremented it to the point that we don't keep looping over. And result is actually going to accumulate after all the calls that we did on this first block to now all the calls that we're going to keep making on the second block until we reduce both of these numbers to 0 one at a time. The reason we do that is because for every loop we do, we're doing one loop for every number we have. So if there's 5, then we're doing 5 loops here, and if there's 3 as a second argument, we're going to be doing this loop and adding 1 3 times, which is essentially saying 1 plus 1 plus 1 and 1 plus 1 plus 1 and 1 plus 1 plus 1 plus 1 plus 1 5 times. And that's basically how we're getting our addition together. And so our last statement here, just return result, what we're saying is we've exhausted a loop of all of these, and we've exhausted a loop of all of these, so our result, therefore, must be the final end addition, which we get when we enter any number in here, 15 and 3. Control S to save, Alt Tab to switch to your browser, and then Control R to reload. It's the same thing as hitting this reload button here, but it's just quicker to, once you practice with the keys going back and forth, it's much faster to use the shortcuts. So great, we've got a recursive adder together. This is our intro to recursion. So if this seems really, really complicated to you, don't worry, it is. That's just the nature of the beast. But the way of putting it together and the thought process of thinking like avoiding infinite loops and traps and reusing variables, all of that complexity, you can kind of reduce down to this one function that says, okay, I take 2 numbers, I add them together. Here's the longest possible route you can go about it. But what we're doing is we're practicing using other functions in the process. We could just as easily say result equals result plus 1. As I said before, these are exactly the same thing. The reason we're doing it this convoluted way is just to practice getting used to visualizing and seeing code that jumps around. Because this is going to jump up to here, then come back down to here, then jump back up to here, then come back down to here, and then it's jumping back up to here. So it's a lot of that tracking where the logic is progressing from one line and statement to the next. That's what we're shooting for here. So it's convoluted, but it's meant to be. That's the whole point. So we've got an adder together. What can we do with an adder? Well, now we can make a recursive multiplier. And in the same way we made an adder, we're just going to define a function. Let's call it recursive multiply, just to be a little consistent. And we'll stick to the same naming conventions as before, just to help us. But instead of carry, let's just call this accumulator, because that might make more sense. Because it's just building up every time we call our function recursively. That's the part that's storing our result. That's the output that we're eventually going to give it. So first things first, we got to make sure multiplication is different than our previous addition, because we didn't have to worry about zeros in our recursive adder. But now we got to worry about num being how do you want to say it? I guess equal to 0. I'll just show you a new operator here. This double equals is a test. It's a test to see if this is equal to this. So the output of this whole block is either true or false, just like this is true or false, and this is true or false. Okay, so if we just did num equals 0, we'd just be trying to assign num1 to 0, which you don't do inside of an if statement. This if is checking for a condition. It's checking, is this true or not? So we have to use a double equals here, and this is a common pitfall because your code won't work if that's mistyped, so be careful of that. And then within our if statement, we're going to open and close parentheses again, and keep in mind this block, the reason we're indenting it here is just for visual appeal. It'll still run without it, but it's contained within these two curly braces here. Also, another way of looking at it, it's like embedded, or another container. Anything within curly braces inside of other curly braces is like a container inside of a box, inside of a case, inside of a shell, so on and so forth. You can use as many as you want, but for readability's sake, it's best not to use them if not to have too many indentations if you don't have to. Or that is to say, branches, they call them. Conditional branches, or lexical scopes is another way of putting it. But anyway, I'm getting far ahead of ourselves. So first we're going to have to check if it's 0. So if this is 0, but see, here's the thing. If num1 is 0, anything we put in num2 is going to be 0, but if num2 is 0, anything we put in num1 is 0. So we almost have to do, well, we could do 2 if statements, which would look a little bit ugly, but we could do another one in here. No, I guess the other way to do it would be down here. So after checking this, we would write is num2 equal to 0. And then we'd write same code in here for if num1. So that's kind of redundant. Let's just bundle them both together because we want the same outcome regardless of whether num1 is 0 or num2 is 0. So we're going to check them both by using this double pipe, I guess it's called. I can't remember. I'm not sure what it's called, but it's the button just above the enter. If you hit shift and / I think on most keyboards it comes up as a pipe. You use 2 of them for an OR. So what we're saying in lexical English is we're defining a function. We're calling it recursive multiply is its name. It's expecting at least 2 values that are numbers. The wording here isn't what makes them numbers. It's just that that's what we're inputting when we're testing it. These values will take anything, but this isn't a programming course, so I'm not going to teach you how to do proper data type checks and things like that for this lesson. This is about recursion. Our accumulator here is what we're going to be using inside of our function when we keep calling ourselves like we did up here. And that's what's going to be storing our result. So I'm going to say in English, if num1 is 0, or the second number we give it is 0, then for sure the entire output we know can just be return 0. And we can say num1 doesn't matter what we put in here, because remember, what we're doing is calling a function we've already defined. And this was one of those building blocks when we're like, oh, I don't know where to get started. What do we do? We wrote a function that says, okay, we'll probably need this at some point. Let's just write a primitive function that takes any value you give it and spits out a 0. That's exactly what we did here. And lo and behold, when we multiply by 0, that's exactly the behavior that we want. So if num1 is 0 or num2 is 0, that is the first or the second number that we input when we call it. And remember, this is how we call it. You call the function name, open parentheses, and then you give it its arguments, or parameters, however you want to call it. I think within the function, they call it a parameter, and then if you're calling the function, they call it an argument. I'm not positive about that, but there is technically, I think, a difference between the names. But let's just give us some room here so that we don't confuse past code with new code. Now, what do we need here? Okay, if it's not 0, then we can just start... oh no, we need our variables first. So let's define the same variables as we did before. we'll use first, second, and result. And I'm going to do this just a little bit differently to show you that syntax, the way that you present code, is very flexible. And over the years, they've come up with new ways of shortening people's code and making things easier to see and read. This is one of those ways they've done it. So instead of taking 3 lines to write the same as I did before, first equals num1, second equals num2, result equals vary, and then let to create all of these scoped, meaning they are contained within these brackets by using the let keyword. Without it, it would give it a global scope, and that would mean outside of these parentheses, you'd be able to use those. We don't want that because we're using the same variables over and over again, so these would they would conflict with themselves if I change these to say just first, second, and result. I gotta change all of this now to make sure that everything corresponds to the variable names that we've chosen. See, without using let, I would start getting conflicts when I try to run the code because each of these functions is using, would be using a global variable by the same name. So if you just make a point to always use let, then you'll never have that problem, and it's just best practice, in my opinion, to save yourself syntax errors, because nothing is more annoying than thinking your code doesn't work because you've typed something in a wrong way rather than the logic itself being flawed, because you're usually focused on just the logic when you're writing code. So we're going to start by telling our function how we want it to run, and we want it to run very similar to our function up here. And how did we start that one? Well, we used an if statement. This one was just to, let's shorten this out. This one was just our 0 function, so anything multiplied by 0 is 0. You don't need to do anything, quickly return. Now we're going to say if first is greater than 1, result equals our recursive adder, and we're going to use second. How are we going to do this? Yeah, second and result. Yeah. So let's step through this. If first is greater than 1, so let's just say our let multiply example equal recursive multiply, so 2 and 3. So what I'm doing here is I'm just creating a variable in our global scope, and then I'm going to write a console log so that I can, there we go. Just so that we have something to quickly save and refresh to make sure that as we go along, we're getting the responses that we want. So right now we'll say it's undefined. The line 128, which is this console log call, which is opening this, which is calling our recursive multiply with using the numbers 2 and 3. Recursive multiply is then taking 2, 3, and I gave it nothing for a third number, so accumulator is going to be set to 0. So let first, second, and result equal num1, num2, and accumulator. So that's what, 2, that one's 3, and then 0 is the default. So what do I need? I want my recursive adder just to take the second result. Yeah, pretty sure that's what I want. Let's test it out. So to make sure that it doesn't loop forever, don't forget we got to say first equals -1 first, and I'm just repeating this over and over again because that's how you learn. It's from repetition. The function we wrote -1 just takes in any something, takes that something, and adds a -1 to it. I just use parentheses here to show you that this is where it's all malleable. You can use parentheses just like you use them in math, regular variables just like you use in algebra. It's all pretty much the same. So first equals -1, and that'll keep it from looping forever when I do this recursive adder call. Now I need to tell it to give me, spit out a result. Let's tell it, let's do a little bit differently this time. Instead of setting a variable and then just returning the variable, let's show you how you can return an entire function, because the function is going to call these same variables that we used before. Remember, we're just following the same pattern. I'm writing it in a bit of a different order just to help you sort of realize the things that you can change and maybe shouldn't change, just to help you get a better idea or a better sense of which parts are malleable that you can manipulate and try and figure out different groups or organizations for yourself. So else. So this is going to call our recursive multiply function using the first number we get, which is going to be -1, the second number we get, and then spit it out into a result. And the result is our accumulator. So the next time this function is called, it's going to have, now we can say result equals recursive adder. And I know this is probably tedious watching me like type and figure it out as we go, but I think it's really critical and helpful even for people learning to realize that it's not about just finishing it as quickly as possible and saying, see, look, I got the recursion done. It's a little bit helpful to watch the process to it, because then you can kind of get a sense that, you know, you're not alone in trying to figure this all out. It's hard for everybody, even if you practiced. Oh, good. No errors. I was expecting an error and that we'd have to debug or something, but anyway, it's taking our 2 and our 3 and it's multiplying them into 6. Let's try a bigger number just to make sure that it's working. Control S to save, Control Tab to go over to my browser, and Control R to reload, and maybe I'll make this bigger so you can see it. There you go. 726. Do I have a calculator? What is 22 times 33? 726. Oh, good. Okay, so our program's working firsthand. First crack at it. I wasn't expecting that. So, good news. What are we going to do next? We've got a recursive adder, and now we're using our recursive multiply using our recursive adder, because multiplication is just addition over and over and over again, so that's a loop. We know we can do that. And then recursive adder for the second set of numbers here. Let's try, oh, well, what if we wanted to just add any numbers that we input, as many as we wanted? There's no limit. Right now we can only put in 2, because if we put in a third number here, it's just going to change our accumulator and it's going to screw up our entire calculation. Like if I put 5 in here, save, and then, oops, and then refresh, it's going to change our output to 371. It's adding 5 to the end because it's starting at 5 instead of 0, and our program's only written to start at 0, and then increment that accumulator as it calls itself recursively and decrements its condition. So let's write a function that takes as many arguments as we want. Let's start with the adder, because adding is easier than multiplying. Add these, and we're going to return a result, which means we're going to need to create a result variable, and we want that result to equal probably nothing at first. So result equals nothing. Well, let's just make it actually equal nothing. We'll be responsible. So what we're going to need to do is we're going to need to use a keyword, and we're going to need to use some built-in functions with JavaScript to tackle this. And I wasn't really expecting to go this far, but I figured since we've already got all of this panned out, and since it worked right off the bat, I might as well give you some bonus material here. Just something to think about and ruminate, and ways to challenge yourself if you're looking for to see the puzzle aspect of writing code. So to do that, I'm going to make an args. So I'm using args as shorthand for arguments, because arguments is the keyword in JavaScript to say everything that gets put up here. But everything that gets put up there doesn't get turned into an array. Like I could just do this, and you'll notice in my text editor, it knows JavaScript, so it knows to change the color of this because it's a keyword, whereas everything else is just white. If you use a keyword, it'll change its color, like the word let changes to that. Console is a built-in, so it changes to blue. So, and as I said before, I'm not sure if I mentioned exactly, Sublime Text is the free text editor I'm using. If you can afford to, support the developer, but if not, it's free, and it'll just ask you once every 100 times you save whether or not you want to contribute to the developer. But getting back to this, so arguments is a keyword that'll take anything that gets put in here when the function is called. So let's create a new global variable, just example, and add these, and 1, 2, 3, 4, 5, let's say. So in the end, when I write this function here, this add these function, I want it to take no matter how many numbers or arguments or variables I give in here, I want it to, let's do that too actually. So let t equal 6. Just to show you that you can throw variables in here too, not just numbers. T is going to just be represented by a 6. Just fun practice, that's all. So yeah, I want any number of variables or numbers that I throw in here, I want it to use in here. Arguments is our keyword, but it doesn't produce a list for us. Remember up here when we were talking about, where was it? Up here, our list arrays? I basically just want to get an array of all of the numbers that come in through arguments, and then I can loop through those indexes one at a time to accumulate the numbers together, to add them up, to make a sum. That's what I should have called this. I should have called it sum. But anyway, we're going to stick with add these. So I need to take from the array prototype, and this is a built-in function of all arrays. You could build an array from and then give it a variable or something. This works with a lot with like web pages if you get they call it like collections or sets. So let's say you've got list items on a web page and you want to make sure that all of those items get bundled into one variable because you want to change them all the same way. You might throw them all into an array and then just apply the same function to every item in the array and then loop through the array. And the array has other built-in functions like length. If you wanted to find out the length, all you'd have to do is, now that I've got args becoming an array from the arguments, which is a keyword in JavaScript. This is a programming language specific thing, so that any number of things I write in here becomes bundled into this, and then it's turned into an array from that bundle. So let's just make sure that worked first of all. So console log args. And what we should see is when I call let example equal add these, it'll have to call this function, which is here. It's going to use all of these arguments, bundle them into this keyword, and then it's going to create an array from those, from that bundle. And now I'm going to console log just this, this array that I've made. This is a variable. You can call it anything you want, but I'm just calling it args because I'm trying to code and write at the same time, so I need to use familiar terminology. So again, I save this page, Control S, Alt Tab over, Control R to refresh, and here you'll see line 138, trusty and faithfully, it prints out our console log of arguments, and in a nice index, well, I guess I should have used different numbers, but I guess that doesn't really matter. T 5 4 3 2 1. Well, 21, that works too. So I save it, refresh. And now you'll see the indexes are sorted again in order that I entered them. So T, which is 6, is the first index, and the first index always starts at 0. And then we've got 5, 4, 3, and then 21 because I missed a comma. So that's how it's important to always check your spelling when you're doing tests. But I'm going to leave it like that because it doesn't matter. It's just a test. So console log our arguments. We don't need, I guess I'll leave that there too. Just comment it out. Remember, anything with the double slash in front, compiler's just going to skip it when it goes through. So I'm going to use another built-in function just to show you how to play around with arrays, show you why they're useful. So args.forEach. ForEach is a built-in function that actually takes a function. And in the function that it takes, it gives you the value for the index that you're currently on, because it's going to go through all of them. That's what the for each is. It's a for loop that goes through each of the array items. And remember, these are all my array items. One of them is just 6, 5, 4, 3, and 21. So it'll give you a value, index, and array in that order. This is how the built-in function works. So every time you use this for each, you can use it on any type of list. I can use it on this list up here too if I wanted. And I could tell it to just console log out each one of these items. That would be a value. That would be a value. That would be a value. The index would be 0, 1, 2, and so on. And the array would just be the name of the array. So every time you call the for each function, it's going to give you the value of the current iteration. It's going to give you an index for the whole thing, and it's going to give you the array. And the way I remember this is I just write VIA, like via rail for the railway, or via like I think it's Italian word for where from. Anyway. So for our purposes, we wanted to go through each one of these, and we want to use our results and our recursive adder, and we're going to use result and v. Yeah, well, I guess that doesn't matter. I can just use v and result makes more sense. So this recursive adder function that we wrote up here, remember, it just takes one number, takes another number. We ignore this because that's what the function itself uses to accumulate before outputting its result. And every time it returns early, that means you know it had to call itself and give itself a carry value to prevent that infinite loop. So now we're going to be calling it again. We're going to be using the value from each item in this array. Now this won't work if you've got something that's not a number, but thankfully we've put in all numbers here, so it's going to work trusty. There's other code you can do for type checking and all that kind of stuff, which is definitely good practice in programming. But again, this is not intended to be a JavaScript tutorial. It's mostly a recursion tutorial with JavaScript as just the catalyst for our ruminations and mental excursions. So after it's done this code, notice how it's not calling itself like it did before, and it's not and it's not looping like we did here with our while loop, where we had to change the value of second in order for this to not infinitely loop. What we're doing here is saying loop, yeah, but only do it once for each item in the array, no matter how many items there are. So if I keep adding stuff to this, doesn't matter how many numbers I put in, the length of this array gets bigger, the number of iterations this gets run and result accumulates, and then after all of this is done, because see how it's wrapped in parentheses, that's the built-in function of the for each. This function is telling it what to do on each of those instances. And that should work, so I'm just going to Control S to save it, Alt Tab over, Control R, and look at that. Our output is 726, and that's apparently what it is to add all this stuff up together. And I guess I should take a calculator and double check, but let's do, we don't need all those numbers to check. Control S, Alt Tab, oops, Alt Tab twice. 130, oh, I didn't, console.log our example. Remember, before I was console logging from inside the function. Now I'm console logging our example, and the example is what calls the function. So Control S, Alt Tab, Control R, now we get 27. Let's just see if that's what 6 plus 5 plus 4 plus 12 comes out to. 27. Beautiful. Okay, so we did the easy one first. Lastly, since we're here and we're going to be doing, let's just do the same for multiply. Let's call it multiply these. Oop. Cancel. Don't know what I did there. Anyway, multiply these in camel case. So we're going to be using the exact same formula as we did up here. So let's start with let result equal 0. Sure. Let args equal array with a capital because it's a built-in. From, which is a function that's built into the array. That's what this dot notation is. This from is a function just like we write functions, but it's built into the array object, which is built into the JavaScript programming language. So you've got numbers, floats technically, floating point numbers, strings of text, arrays, which are like lists, those are in square brackets, and then objects, which are key value pairs. So instead of having an index that goes incrementally based on when it was inputted to the array, it's a key value pair, so you can actually use a variable name as the key instead of an iterable index. So instead of using an index number like we used in the other arrays, it's only indexed by the name that it's given, and those are unordered lists. So that's another way of thinking about them. So when you iterate through an object that's just key value pairs, then there's no way of knowing which came first or second, and it doesn't sort them out. It's just the first one that pops into memory is the first one it spits out if you ask for it to tell you what's in it. So maybe we'll do another. Yeah, objects are really good to know for just a separate lesson altogether. But okay, focus. Multiply these. So we're going to do arguments from, just like we did up here. So array from arguments. Let's do that. And then we're going to have to do args for each. I'm going to use another notation. It's equivalent to just the bare function call like we did up here, but I'm just going to expose you to some more JavaScript shorthand just for the sake of interest and being repetitive but not being redundant, or vice versa. I'm not sure which is better or worse. Anyway, yeah, so this is value. Let's, just so that you know you can change these, index r. Those can be whatever you want. You just use them when you want to reference them inside of this loop here. And keep in mind, they're only valid variables from within the scope of these parentheses. And that's why we're indenting, because this whole thing is within the scope of this function, and this whole function is within the scope of our script tag, which we've also indented up here. Okay, get to the point, Chris. Finish this. So result equals recursive multiply, and we're going to use result and val. So this result is 0. Ooh, is that going to work? Oh, I'm going to have to just test it. Yeah, let's just test it. So we've already got example up there and we've console logged it. So let's say example B, or no, final example. Let final example equal multiply these. And remember, the point of this one was that we can give it as many arguments as possible. That's why we're writing a whole nother function for this, because our original function, if we added more numbers to it, it would replace the value in the accumulator and it would stop the recursion part from functioning as we want it to. So what we're going to do is compartmentalize this function, just like we bottled these functions inside of our other functions. We're going to now bottle our package, or bottle, contain a recursive multiply function, which can't use a whole bunch of variables, arguments input. And we're going to recursively multiply, giving it the value. I think this has to be 1 because multiplying by 0 wouldn't work at all. So result has to default to 1 in the case of multiply. But you started off with 0 in the case of addition. That makes more sense to me now. Yeah, so result will be 1 times the value. So you basically, it's kind of cheating, I guess. I didn't really do this very well. But for every value that I give it in my trial example, let's say 1, 2, 3, 4, 5. it's going to do a loop through here, and then each time it's going to do 1. 1 times 1 is 1. And then the next time it loops through, it's going to do 2. So 1 times 2 is 2, and then it's going to do 3. 3 times 2. Yeah, you'll see. Anyway, so Control S, save, Control R. Oh, and I forgot to console log it again. You'll see how often we use console log because it's super helpful in stepping through code, but there are better ways of debugging, but that's definitely for another tutorial. Undefined at 159, this long here. So example final. First thing to check, did you spell it right, Chris? Yes, you did. Multiply these. What if I give it a 0? Let's just test our 0 case. See if it's working at all. No, it is not. So our result equals 1 for each. Then we use a recursive multiply. Oh, we didn't return anything. Notice the function will do all the calculation, but if you don't tell it, because I'm assigning a value to it, I'm saying this has to equal whatever this outputs. If I don't tell it to output anything, obviously, the asking it what the variable is going to say, I don't know, you didn't tell me what it is. So, we're going to output results, because that's the number that accumulates over all of these multiplies. And there we go, I was hoping we'd have a problem, so we'd have something to discuss on here even. Okay, so our 0 works. Let me add like 100. Save. Let me try it on the other side. 1000, 0. Great, so our 0 works. Let's see. Here's the big drum roll and the big finale. Control S to save, Alt Tab over, and Control R. Booyah, we got 230. That's 23 times 10, 230. So yeah, that's pretty much it. That's primitive recursion in a nutshell. We start with our primitive basic blocks, just an add 1 to anything, make 0 out of anything, minus 1 to anything, and our easy multiply, where we just use our multiply symbol. Nothing to it, enter numbers, good to go. Then we made a loop adder where we threw in a loop and did the addition one at a time while decrementing our iterator, or our counter if you want to say, and then adding 1 to our result every time we go through. So if this is 5, it runs 5 times, result is going to get a +1 5 separate occasions, leading to a final result. And I should have actually... Here's another error that we didn't catch before. I should be returning the result. Otherwise, when I try and use this function to assign it to a variable, or when I ask the console log to... if I ask the console log to print something out, it won't know what to print out because I didn't tell it to return a value. So let's call this looper. Or loopy, and we're gonna call our loop adder, we're just gonna do 4 and 3, why not, and called it loopy. Remember, I'm doing it quickly just because muscle reflex, but Control S to save the text file here. Close without saving. Save. Control S to save the text file, Alt Tab switches your view over to the console, and remember the console is detachable or attachable. You can change its position, slide it around, doesn't matter. And this is just a regular web page, web browser. And as you can see, our code runs perfectly smooth. So I hope you enjoyed that. I hope you'd bend your brain a little bit, but you can see how this might be fun to just play around with different permutations of variables and adding functions and sticking them inside of other functions and then wrapping a function around itself and around others, and all the different ways and complicated things that you can, the ways that you can manipulate different pieces of information to arrive at the same output conclusion. Like, we wrote all these lines of code when literally all we're doing is this. That's all we did. But the way we made the computer do it, we made it work for it. So we did it one at a time, adding everything through recursion. And the benefit to ourselves is the way we go about trying to tackle a problem that's this simple and we make it complicated for ourselves. The way we go about tackling that problem is what we get as a benefit from our thought processes and our approaches to problem solving. So I hope you can see why I was so enthused about doing this project, and if you did enjoy this content, please give it a like, share, subscribe, that kind of thing. And I apologize for the video quality. This is our first screencast recording, so hopefully everything went well. But stay tuned to Frivolous Gravitas, our weekly podcast where we have substantive conversations, uncensored, about topics of interest and just things that are sociologically relevant and important to the modern day. Cover economics, politics, yada yada yada. Anyway, this video is done. Take care.